This is another case where our dot product comes in handy. So if your dot product is equal to 0, that means that the vectors you're looking at are perpendicular. So this first question is asking us to show that. So that means that we should get to the point where we've got A dot B equals 0. If you don't, you've done something wrong. So A dot B is 4 times 1 plus negative 6 times 4 plus 10 times 2. So that's 4 minus 24 plus 20, which equals 0. Therefore, so remember your 3 wee dots for therefore, A and B are perpendicular. So remember, if the question asks you to show something, always round it off nice and simply by saying, this is me showing you what you've asked me to show. So always put a wee statement at the end. This one's a little bit different. So we're told that the vectors C and D are perpendicular, but this time we're asked to calculate one of the components. So if we do C dot D, that is going to be equal to 0 for perpendicular vectors. So it's always nice at the start to write out the knowledge that you have. So how are you going to be able to show this? Well, I'm going to be able to show it because I know that my dot product is going to be equal to 0 for perpendicular vectors. So always try and be as clear as you possibly can. So for this one, C dot D is going to be 3 times 4 plus negative 5 times by negative 2 plus 2 times K. They're perpendicular, so it's equal to 0. So we've got 12 plus 10 plus 2K equals 0. And I can just work through it as an equation from there. So 22 plus 2K equals 0. 2K must be equal to negative 22. So K must be equal to negative 11. And if you wanted to check that, you could put it back in up here as your value for K, just to double check. But my answer for this one is going to be K equals negative